This is the screencast for section 10.3, example 5. Now we're going to get into calculus of polar curves. We're going to find the slope of a polar curve. Now remember, a slope or derivative is dy dx, so in this case it would be dy d theta over dx d theta. If you think about that, the d thetas would cancel out and you'd get dy dx. So example 5, find the slope of the rose curve, r equals 2 sine 3 theta, at the point where theta equals pi over 6, and use it to find the equation of the tangent line. And then we have a figure that we'll see in a second that'll show you what that looks like. Alright, so first of all, I know that I need to find dy d theta and dx d theta. Well, x itself is r cosine theta, y is r sine theta. And it tells me that r is 2 sine 3 theta, which means that x would be 2 sine 3 theta cosine theta, and y would be 2 sine 3 theta sine theta. So now that I have x in terms of theta and y in terms of theta, I can then calculate dy dx and evaluate at pi over 6. I'm going to take the derivative of the y expression in terms of theta, be careful, y goes in the numerator, and then divide by the derivative of the x expression in terms of theta, and then evaluate that at pi over 6. Now of course I could do that by product rule in the numerator, product rule in the denominator, plugging in pi over 6, etc. But I'm just going to do this one on my calculator because we already know how to do that by hand. And I get negative 1.732, which is negative square root 3. So that's our slope. That's our dy dx, the slope of the tangent at the point on the rose curve 2 sine 3 theta when theta equals pi over 6. Now we just need to find an x and y coordinate to get the equation of that line. Okay, well the x coordinate we said was r cosine theta, or 2 sine 3 theta cosine 3 theta. So x of pi over 6, I plug in pi over 6, I get square root 3. Y of pi over 6, I take the y expression, plug in pi over 6, and I get 1. Which means then my equation of my line is in point slope form, y minus 1 equals the slope negative square root 3 times x minus square root 3. And that looks like this. So we have our beautiful little rose curve here, and the tangent line at the tip of that rose curve, just by coincidence, with this equation. Now try problem number 39. Says find the slope of the curve at each indicated point. So we only need the slope of the curve. We don't need the whole tangent line. Well, if r equals negative 1 plus sine of theta, and theta equals both 0 and pi, so those are the 2 points we're trying to find. To find the slope, I need dy d theta and dx d theta. Well, x is r cosine theta. They told us what r is. It's negative 1 plus sine of theta, which if I distribute, then I get this expression. Now take the derivative, dx d theta, and derivative of negative cosine is sine, but then I have to use the product rule for the cosine theta sine theta. And then simplify a little bit, and here's what I get for the dx d theta. Y is r sine theta, so if I plug in r and distribute, I get this expression for y in terms of theta. Dy d theta then would be the derivative, and don't forget chain rule over here for sine squared. That means dy dx is going to be dy d theta over dx d theta, which then in turns out to be this expression dy d theta over dx d theta. And they want that at both 0, theta equals 0, and theta equals pi. Well, at theta equals 0, if I plug in 0 for theta, pretty straightforward calculation, I get the slope equals negative 1. And then at theta equals pi, I plug in, again, pretty straightforward, I get the slope equals positive 1.